Today we would like to teach you about FIR using the window method. First example, design a FIR low-pass filter to pass the band edge frequency of 0.25 kHz and sampling frequency of 1 kHz with 11 coefficients. Draw the linear phase FIR structure and apply the rectangular window. So for these questions, we need to do for the solutions. So for first thing, we have to determine all the parameter in this statement. So from here, we know that the bandwidth frequency is 0.25 kilohertz. So FC equals to 0.25 kilohertz. Then we have a sampling frequency is 1 kilohertz. So sampling frequency Fs 1 kilohertz. Then we have our 11 coefficient, which means n equals to 11. Then we have to draw and design. So first step, we have to find our omega c, which means is our cut-off frequency. Omega c equals to 2 pi fc divided by fs. So now our band edge frequency fc is 0.25. So 2 pi 0.25 kilohertz divided by 1000 hertz. So we just put in our calculator. So you see from here, so we have 2 multiply 0.25 exponential of 3, then divide by 1000. So we get 0.5 pi. So pi divided by 2 from here. Then second step, we want to construct the HDN. So HDN is determined from the H exponential j omega. So from here we know that from these questions, we know that it's a low pass filter. So we have to draw this line. So from 0 until pi divided by 2 is low pass. We allow here to pass. Okay. Then pi divided by 2 until pi is the band stop. Okay. Then this thing we have to repeat for the negative side and the positive side. So we one more add here. Okay, so this one we will add one more at negative side. So it's negative pi divided by 2 until negative pi. So we can construct our HDN, which means okay, we can see here when 1, so here have the value of 1. So from 0 until pi divided by 2 and 0 until negative pi divided by 2. So we put it modulus omega c from 0 until pi divided by 2. And the otherwise, other than this value, here are 0, here also is 0. So we put it as 0. Then we go to step number 3. So step number 3, we have to find the HGN represent using the IDTFT, inverse discrete time Fourier transform. Okay, so this is HGN equals to formula of discrete time Fourier transform 1 divided by 2 pi integrate from negative pi until pi hd exponential j omega. So it's this one. So we multiply with our exponential j omega n dw. So now we know that the value are here is 0. So we don't have to consider the value from negative pi until pi divided by 2. Okay. And also we know that from pi divided by 2 until pi also is 0. So we don't have to consider these two parts. So we just consider the area of this one. Okay. So 1 divided by 2 pi. So integrate from negative 2 pi, negative pi divided by 2 until 0. So exponential j omega n dw. So then we plus with the area under the graph here. So integrate 0 until pi divided by 2. So exponential j omega n dw. So we know that the value here is 1. So we substitute 1 inside. So 1 multiply anything, we will get back the exponential j omega n. Okay, now we substitute our, after integrate, you will get exponential j omega n divided by jn. Then you substitute your negative pi until 0 into your equation. Okay, this one is after integrate. After integrate, then we substitute 0 inside exponential j and 0 divided by jn minus exponential j and minus jn pi divided by 2 divided by jn. Okay, okay, because this is minus pi divided by 2. And then we plus with exponential j and pi divided by 2 divided by jn and minus of exponential jn. Okay, now it's 0. Okay, until jn. So we take the above divided by minus below. Okay, okay, then we get this equation. Okay, after that, we apply the Euler formula. Sin omega n equals to j omega n divided minus exponential minus j omega n divided by 2. Okay, so this thing we can compare with this equation. Okay, this equation. So we take out our pi n. So we will have 2 here. So this one is our value. Okay, and then plus with another area. So it's this one. So same, we take in our 2 multiply inside. So our pi n we take out. So we will have the value here. So, and these two, after you convert, you will get sine pi divided by 2 n. Because here is 0 already. This one is 0. Minus of is 0. Because this one multiply, you will get exponential 0 and exponential 0. So exponential 0, so we minus off, we get 0. So we just focus on this. So here is, you will get sine pi divided by 2n. Okay. So you will get sine pi divided by 2n for this area. Okay, so this one you will get 0. Okay, then you find, then we go to step number 4. We have to find our HD and window rectangular. Okay, and also we have to find our HN. Okay, so we draw a table. Okay, and so our HDN, WR is our window for rectangular. HN. Okay, HN is obtained from HDN multiplied with the window rectangular. So we know that window rectangular is equals to 1. This is from the formula. Okay. Then we do this one. Okay, and so now we refer back our questions. Our coefficients is equals to 11. N is equals to 11. So for here, we will have our 11. We will have uh, to get this n value, we will have our m minus of 1 and then these 2 bracket divided by 2. Okay. In order to calculate this one, this is our small n value. Okay, so this value we can calculate by equal your 11 minus of 1 divided by 2. So 11 minus of 1 is 10 divided by 2, you will get 5. Okay, and this value, this n value, we just let it n lah, the n. So this n value, so is total is 5, but positive and negative. So we will have n equals to, okay, 0, okay, 1 and minus 1, 2 minus 2, 3 minus 3, 4 minus 4, and 5 minus 5. Okay. We will get back this value. Okay. And then we substitute this value into our this equation HDN. So now we can calculate. So 1, okay, divide. So we have bracket 1 divided by 3 pi. So now we have the value of n is 0. So we multiply nearest to 0. 0.00001 because it's limit. We cannot put it as 0. It will become error. Okay, so you multiply with sign bracket. You will have pi pi divided by 2 multiply with your n also is 0.00001. Okay, so you do like this and you equal, you will get 0.5. You get 0.5, so we put in 0.5. And then you repeat to calculate 1 and minus 1. Okay, now we repeat calculate 1. So same also, we put in the value now minus 1. Okay, another side, here our n also is minus 1. Okay, so you are putting minus 1. So enter, you will get 0.3183. Then you repeat to calculate minus 2 or 2. 2 and then you repeat calculate minus 2. Okay, you get 0. Then you calculate for 3. Okay, want to know whether minus 2 and 2 is the same, so we delete the negative. Okay, then here also we delete the negative. So you also get back 0. So you repeating calculate minus 1 and 1, 2 and minus 2, 3 and minus 3 and 4 and 5. Okay, you're repeating doing with calculator. Then this Wn and Wr rectangular n is equals to 1. So always is 1. Then you take this 0.5 multiply with 1, you get 0.5. You take 0.3183, you multiply 1, you get the answer here. Okay, you repeat until n equals to 5 and negative 5. You will get 0.06366. Okay, so after done this one, we will go to step number 5. Step number 5 is to find our HZ transfer function. Okay. Step number 5, we want to find our transfer function. So how you want to do to find our transfer functions with the window? Okay, so what we do is we are using n, so you write back negative 5, 4, 3, 2, 1 and 0, 1, 2, 3, 4, 5. Okay, then hash n, okay, you write back the value here. So 0.0636, 0 minus 0.106, 0 and right until n equals to 5 lah. Okay, here. Then we using this formula. So we have two formula, this one to find our transfer functions, the jack of the filter with the window, and also this is a transfer function for the realization filter. So this one is a transfer functions for the filter, this one is for the realization. Okay, so we are using this formula H Z equals to summation m minus 1 divided by 2. Okay, m minus 1 divided by 2 here, so negative, so we will from 5 until negative 5, and hn, and z minus n. So hn is the value that we calculate here, okay, and at the second column. Okay, so now h n minus 5, so z minus 5. So because it's here, okay, so this one is minus, okay, minus 5 here, okay, your z, okay, minus, so n, your n is minus 5, so minus 5 here, so bracket, so you will have 0.6366 z minus 5, you will get plus 5. Okay, this is your answer. Then you repeat for minus 4, so here z, okay, minus 4, you get positive 4. So you know that this one is 0. So 0 multiplied with the z, power of 4 also is 0. Then you repeat for n equals to 3, negative 3. So h, negative 3. So z. So z now minus 3, you will get plus 3. So you will get 0.6106 z power of 3 plus 3. Okay, so you repeat do for all the value. Then after that, okay, now this one is the transfer function realization for realization filter. Okay, transfer function of realization filter. So h prime z, so I just type in here. So for your understanding, okay, this one is our transfer uh, functions for the filter. Okay, this one is a transfer function. Uh, transfer function for realization. Okay, so you repeat again. Now you will have hash jack. So something that you calculate from hash jack here. So you multiply with z minus m minus 1 divided by 2. So now you will have m minus 1 divided by 2. So this one is minus n. Okay, this one is minus your n. Okay, so you start off here. So here initial you will have 0.6366. You will have power of 5, right? Then now you have to multiply with negative n. So negative 5. So 5 plus with negative 5, you will get 0. So z power of 0 is equals to 1. So 1 multiplied with 0.6366, you will get back 0.6366. So you repeat for this one, minus 4. Okay, so 0, multiply anything, get 0. So for here as well, you repeat negative 0.106. So bracket z power of 3, then z minus 5. Okay, then you repeat, you multiply. Okay, so 3 minus multiply with negative 5, so it's 3 plus negative 5, so you get negative 2, power of negative 2. Then you repeat for all, so you get this answer. Okay, now we write out the transfer functions. So we have the transfer function hash jack is 0.5. So we start from the middle lah, h. We start from the n equals to 0. Okay, n equals to 0 is 0.5. Then plus with, okay, h n minus 1 and minus n 1 lah. H n minus 1 and n is 1. So 0.3183. So you will have, you will have this one minus 1 and 1, z power of 1 and z power of minus 1. Then this one for n equals to 2. So you do, okay, 0. Then we write for n equals to 3 and n equals to minus 3. So we will have 0.106 z power of 3 and z minus 3, power of minus 3. Okay, then we do for number 4, n equals to 4, okay, it's 0. N equals to minus 4, so it's 0. Then we do for n minus 5 and n 5. We write down for the equation hash prime also. Hash prime, okay, so we will have 0.6366 minus of this one, and okay, because it's a minus, so plus with this one, plus with this one, minus this one, and plus with this one. Okay, then we get a function like this. Now we want to draw the realization. So how to draw? So these questions, they ask to draw a linear phase for FIR. So we follow the title, linear phase FIR. Okay, so we draw a linear phase FIR. How we draw? So by follow just now the equations, Now input is xn. Okay, so you enter. So the first one you will have z minus 1. Okay, then because now you know that you will have z minus 1 until z minus 10, the last one. So you keep drawing. So z minus 2, then you will have z minus 3, then you will have z minus 4, and the last one z minus 5. Then you will until z minus 10, right? So you will have down here z minus 6, z minus 7, z minus 8, z minus 9, and z minus 10. Okay, okay, now you draw here. So this one is go here. So you have the arrow, everything. Okay, until the last one. Okay, so now you start with first one is you will have we start with the z minus 5. Okay, you, first thing you will have 0 point, the first one okay, without have z we will have the first one. So you go down here, first one you will have the first one is 0.6. Sorry, is 0.06366. Okay. And then this one is the last one as well for the H, for the H10, Z minus 10. So you go here, so have an eraser here, so you will have plus this one and the first one. Okay. Okay. Then you go back to the -2 and negative 2 is same with -8. So negative z minus 1 minus 2 and same with, so minus 2 is minus 1. So minus 2 is here. So you go down. Okay. Is same with minus 3, 4, 5, 6, 7, 7, 8. So these are minus 8. So you go up. So you add up here. So you go down. So you have a multiply with 0 point. This one is negative 0.106. Then you go to the next one. So now you will have minus 4, z minus 4, and z minus 6. So you count 1, 2, 3, 4, z minus 4, you go down. 1, 2, 3, 4. So number 4 here, you go down before number 5. Then you will have minus 8, minus 6 is same. 4, 5, 6. 6 you go up. So you add up. Okay, then you go down. So this one you multiply with, okay, is g, no, minus 6 is 0 0.3183. Okay, then the last one is when this one z minus 5 is multiplied with 0.5. So 1, 2, 3, 4, 5. So 5, this arrow you go down before you multiply with number 6. So z minus 6. So you go down here. This one is okay, 0 0.5. 0 0.5. Okay, then you go down. So everything you go down. Okay, so you link it up. So you go to the arrow. This one is okay. Okay, so you go up. Okay, this one is your y and your output. So done for your this one linear phase FIR. Okay. So do you have any questions? If no, then done for linear phase. If you want to draw a direct phase, is just direct. You draw a straight line, then you go down for everyone, then it add up lah. This is a direct one. So this one is linear. Okay. So if you want to draw for direct, now we draw for direct FIR. Okay. For direct FIR is more easier compared to linear phase. So you just have to xn, then you draw for one line. Minus 1, minus 2, minus 3, then minus 4, then minus 5, minus 6, minus 7, minus 8, minus 9, then minus 10. Okay, like this. Okay, so then it multiply for each one. So this one you will go down with 0.06366. Then at number 2, 1, 2, and 1, 2 here you go down, you have minus 0.106. Okay, then 1, 2, 3, 4. So number 4 you go down here. So you will have 0.318356. So 5 is 0.5. So 6 is 0.3183. 6, 7, 8, 8, 8 is negative 0.106. And the last one, number 10. Okay, you draw down, you will have 0.6366. Then everything you have to connect each other. Then you go out. This one is your YN. Okay, this one is direct forms FIR. Our questions here. So we continue to find the frequency response. Okay, to find the frequency response representations, we using the equation. Here. Okay, modulus h exponential j omega then equals to h m minus 1 at 11 minus 1 divided by 2. So you have 5 lah. So summation m minus 1 here is 5 also. And n equals to 1, 2, and then m minus 2 divided by 2 and minus n. Then cos omega n. Then you calculate, you will get m minus 1 divided by 2 is 5. So here also is 5, here also is 5. And the cos. Okay. Then you put in the calculation. So you know that h power of 5 is 0.5. Okay, then this one 2h4 cos this one. So you know your h4 is 0.3183. So you just put in, so cos. And then this one we know that h3 is 0, so it's 0. So that's why we do for here. 2 multiply 0 point h2 is 0 is this one, because it have negative, so we multiply with become negative. So 0.106 cos 3 omega and this one. Okay, then at the end we get this equation. Okay, so we get this equation. Then now we set this omega with 0 pi divided by 6, any value that you can set, but normally we'll use 0, pi divided by 6, pi divided by 3, pi divided by 2, 4 pi divided by 6, 5 pi divided by 6 until pi. So in the interval of pi divided by 6 lah. Okay, then we put inside this equation. So you just have to type 0 inside your calculator, 0.5 plus weight. Just now you have 2 multiplied 3, 183, you will have 0.6366 cos. Okay, now you put in your cos, value is 0. So remember everything calculated in radians, then minus of 0.216. So cos, okay, now you have 3 multiply your so your pi is how much? It's 0. Okay, so it's 0. So bracket, then you plus with 2.18. Okay, 3 times 0, 3 times 0. So then you plus with the 0.12732 cos. Okay, now you will have 5 times 0. So you will get the answer. Oops, like I have something wrong in my calculation here. 0.5 plus with, oh, this one cos 0. Okay, I forget to put bracket. And minus of 0.2126 bracket 3 times 0 bracket plus with 2626 plus with okay, 0 1 plus with 0.1273 cos bracket 5 times 0. Okay, so you have to type in 0.5 plus 0.6366 cos 0 minus of 0.216 cos 3. Okay, 3. Then multiply with 0. Then plus with 0.1273. Okay, cos 0, 5 times 0. Okay, you will get 1.5132. Okay, so get these answers. So you just write in 1.5132. Then you repeat for the first line. Then you also repeat for below. Okay, below you will use this value 20. You log your answer. So you'll get 0.43469. So you get this one, 0.4345 or 46. So you repeat to calculate all these, and then you draw the diagram for your sketch the diagram for magnitude response plot. Okay, then done for this question. Okay, thank you. Remember to subscribe my channel. Bye. Thank you. Bye bye.